The most expensive recovery reflex is also the simplest. Rerun everything. Data Culina starts with a different question. Where did the first real failure occur? A failure is a location in a dependency chain, not permission to reset the whole platform. The framework turns that location into state you can inspect, contain, and recover. It does not promise that pipelines never fail. It gives operations a controlled path back from the smallest safe point. That is where this final episode begins. Validation starts before any rows move. Metadata and configuration must be usable. The export envelope must identify the artifact and client scope. Source reads, transformation references, aliases, and the target write contract each have their own readiness checks. Then comes a detail that matters in practice. The current transformation workflow writes the target first and runs enabled unit tests afterward. A failed required test blocks successful completion, but it does not automatically roll the write back. The runtime currently supports 3 test families: data integrity, duplicate business keys, and null business keys. Data integrity is count-based for ordinary targets, or a residual new or changed check for an SCD2 target. Those checks are deliberately narrow. They do not prove every business rule, perfect history windows, or correct tombstones. Only enabled checks run, and the current code returns completed when none are enabled. Metadata policy and deployment configuration still matter. When execution ends, the workload returns structured status and diagnostics. That returned JSON is useful, but it is not the official control plane record. The orchestration finalizer interprets it and writes the queue status, run history, and failure evidence. Operations can then read 4 surfaces together: job queue for current state, job run history for the failing step or zone, job failure log for the error, and unit test results for quality evidence. The goal is the earliest true upstream cause, not the loudest downstream symptom. If a returned failure still has retry allowance, the queue row moves to on-hold retry. The retry counter advances, a future retry time is recorded, and the child later promotes the row back to pending when that time arrives. When retries are exhausted, the row becomes failed. Dependent unresolved rows can become skipped because they never became executable. The failed batch does not quietly close. Terminal failed remains unresolved for batch completion. That is containment through explicit state. Retry and rerun solve different problems. Retry is automatic and bounded. It assumes the same configured work may succeed on another attempt, perhaps after a transient source or service issue. Rerun is manual. An operator investigates, fixes the cause, then resets selected unresolved work for another attempt. Completed rows are not normal rerun targets, and if a parent loop is already active, operations should let it drain the queue instead of starting a duplicate. Recovery also has 4 different verbs. Rerun executes the same configured logic again. Replay sends data that is already available upstream through downstream processing. Backfill restores historical coverage that never arrived correctly. Rebuild recreates a target from trusted upstream data, most naturally a transient layer. These are not interchangeable buttons. The right choice depends on what failed, what data is still trustworthy, and how much state must be recreated. Minimum scope is a decision, not an automatic calculation. Operations pin the earliest failure, inspect dependency impact, and choose only the affected path from that point forward. Work already completed stays behind a protected boundary unless there is a strong reviewed reason to touch it. That may mean rerunning one failed queue row, replaying transformation from existing staging data, or backfilling a missing period. The sequence is always the same. Identify scope, confirm root cause, fix it, then recover only what is needed. Recovery must also respect the layer. Staging keeps its append and retention behavior. INT is the main rebuild boundary because it is transient and truncate load. Facts keep their append or latest version rules. Dimensions must still preserve SCD2 history, hash comparison, full state reasoning, and tombstones. Afterward, prove the original defect is gone, check for duplicates or false history, confirm downstream outputs, and record what failed, which method was used, the scope, and any follow-up. Across this series, every layer has pointed to the same idea. Metadata captures intent. Contracts make it portable. Layers separate responsibilities. Queues control execution. Payloads cross the orchestration boundary. Load rules govern ingestion. SCD2 protects history. Validation and recovery close the loop. Trust does not mean pretending failure never happened. It means the failure is visible, its evidence survives, and recovery has a safe boundary. That is the framework under the hood. This is Inside Data Culina. Explore the complete approach at datacalina.com.